The next generation that you're talking about is to have everything on single probe card, because today you're still talking about having silicon photonics application layer and hybrid electric probe card, so you can test both of them. But those are more hybrid solutions that we have to look into the future roadmap, collaborating with partners and suppliers.
Hello and welcome to Advantest Talk Semi. Today I'm your host, Keith Schaub, and we're zooming in on the last few millimeters between silicon and certainty, the probe card. My guest is Ashutosh Deve, Chief Commercial Officer at FormFactor. Ashutosh brings more than 2 decades of semiconductor know-how from process engineering at AMD to 9 years leading global metrology inspection at ASML before taking the commercial helm at FormFactor in 2024. So FormFactor itself began life in 1993 when a tiny New York lab turned a microspring epiphany into a new class of probe technology. Here we are 3 decades later, and the company is the world's #1 supplier of advanced probe cards and engineering probe stations, having shipped over 115 million MEMS probes every year to fabs tackling everything from HBM stacks to quantum qubits. So in the next hour, we're going to unpack this journey. We're going to explore the toughest probing challenges ahead, and we're going to hear how FormFactor is keeping electrical integrity intact at 112 gigabits per second at minus 40 degrees Celsius. So grab your coffee and your curiosity. This is going to be a masterclass in the art and science of first contact. Okay, so Ashutosh, welcome to Advantest Talk Semi.
Thanks a lot, Keith. I'm actually very privileged, and I'm honored to be over here on the talk show along with you. A little bit about myself. I grew up in India. I started my career as a R&D litho process engineer. I was a metal implant layer owner. So I was working on those, and then what happened is AMD expansion split. And now you're a process engineer working in the clean room, and you don't have a fab. What do you do? So then eventually what happened is I moved on to more onto the computational lithography side, more onto the software side. We call it optical proximity correction. Then I transitioned from clean room to more onto the desk. There was a time when I moved from AMD to a company called Mentor Graphics. So they were a supplier who was providing solutions on this resolution enhancement techniques and optical proximity corrections. So more onto the design side. And that's when I transitioned from hardcore R&D to more onto technical marketing. Eventually, I moved on to sales and business development. So I've done front-end process, I've done front-end design. I got very familiar with not just the back-end design aspect, but also the front-end design aspect, because now you're talking about this entire design for manufacturability, DFM, place and route, everything. I was with Mentor Graphics for about 8 years, and then I transitioned to ASML. I got more into the actual core lithography area. That is when I got introduced to back-end test and measurement, actually, because so many times on the inspection side, you still want to see whether the defects are real or not. And that's where the probe really comes into the picture. And I knew Mike Slessor, so that is when he asked if I would be interested in joining FormFactor, and that's my journey.
Yeah, we're happy to have you. We've been collaborating in certain spaces like silicon photonics, which we'll get into later. We're actually on 2 opposite sides of the same coin, because you spent most of your career in the front end, and I spent most of mine, almost all of my career in the back end. And it would be interesting to hear now that you're on the better side, let's say. So you joined the better side. It would be interesting to hear how you see that landscape has changed and the differences between what's going on in the front end and the maturity levels, and how that's different with the back end. So
so let me begin. I don't think it is 2 different sides, right? I would still say that we are all serving the semiconductor ecosystem widely as we evolve all these product and technology in the industry overall. I would say front end, it has its own challenges. It was one of the driving factors of the device technology and the growth that we have seen in the semiconductor industry for many years. Whereas the back end was more as a commodity market for many years. And what is happening is if you start looking at where the industry is headed, we have our own challenges driving down technology from, many generations down to 10, 7, 5, 4, 3. And now we are talking about angstrom level. So front end still has its own challenges, and there are companies which are working hard on that. But what is also happening is the back end, which now we start seeing all these yield challenges. The known good dies become a lot more critical, and the cost of test and measurement for not basically letting go some of these bad dies, the cost is becoming quite significant factor, which what customers want is they want to solve these issues. And this is where the test and measurement now is becoming, I don't want to say a bottleneck, but one of the areas of focus
Mm.
to ensure that there are better known good dies, and overall we can produce more reliable and high quality product that goes into the end consumers.
Yeah, so you mentioned the migration or the value shift from commodity to enablement,
Yeah,
where we're also, as Advantest, a semiconductor test supplier,
yeah,
we view ourselves, and most of our customers now view us as a technology enabler, and it's
yeah.
an essential part of the ecosystem. Let's look at that in terms of the markets and technology for a moment. So FormFactor, you guys obviously make probe cards
Yeah,
to address probe challenges,
yeah,
primarily at wafer, but for all sorts of different technology slices. So you have
yeah.
logic, you have memory, you have RF. Sort of walk through what are those different technology slices? How do you guys slice it up? And
Yeah.
then what are some of the major challenges that you see from one to the other, or are they all very similar?
No, they're very different actually, and you bring a good point, right? So if you look at this entire semiconductor ecosystem, and if you break it down by market segment, right, each segment has their own challenges, right? So what I was talking about back in test and measurement becoming mainframe, where it needs own development and more emphasis in terms of what concerns are there in terms of the yield and known good dies. Break it out into different segments, right? You look at logic SoC devices, one segment, memory, and even in memory, then you split it up between DRAM, NAND, NOR. But more important, what is happening is with the AI inflection, basically we are seeing quite some challenges on the HBM, high bandwidth memory.
Hmm.
So that has its own requirements. And you then also look at the other sectors like, auto industry. You look at RF market. You look at, the mobile. So there are many different segments, and each of these segments, the technology is becoming challenging. Back-end test and measurement has its own requirements for each of these areas, and that's where we are focused on. So if you look at FormFactor, we are the only company that provides and serves this entire spectrum of industry today.
Interesting. So all these different segments, same for Advantest. We have different modules and different tester capabilities that serve different markets. Since obviously AI and HBM is sort of the hot topic
Yep.
in the global industry today,
Yep.
maybe let's focus in on that one and talk about what the probe technology looks like and the challenges for that specific market. I think I remember reading FormFactor recently won Best Supplier Award from
Mhm.
SK Hynix and maybe
Yep,
something from
yep,
Tech
yep.
Insights. Can you talk about that a little bit?
Sure. So let me segue this into different areas, right? So FormFactor has been number one probe card supplier today, and we do win a lot of accolades from customers like Hynix. We won. We basically got the number one supplier award. We get similar from other customers too. Not only that, recently we also got awarded as the #1 supplier in the sector from Tech Insights. So it's not just from the technology that we get testament and basically awards from the customers, but we also get more from customer satisfaction point of view, right? So it's not just technology, but it's also how you support the customers. And there's a lot of work that goes behind getting these awards, right? As you can imagine. And this is the work that we put in over the years, right? So, over the years, what has happened is there are many challenges. You talked about AI, you talked about HBM, right? If you focus on that for memory applications, and especially for high bandwidth memory applications, we have solutions that basically we call it smart matrix products. So that kind of product is needed for when you start talking about HBM, the bandwidth requirements, the requirements that, you're talking about stack die, you're talking about base die, core die, but more so important, even having, known good dies at wafer level. Can you do one touchdown solution versus what are the lifespan of these probe cards? But if you get into more technical details, the more technical details are how do you have reliable solution that gives you the basically what we call, we measure in terms of current carrying capabilities or force and the pitch requirements, but there are many more details that are required from each probe cards and the technology that goes behind it. And we have been working very closely with the customers to make sure we have solutions that resolve the challenges that customers are facing today.
Okay, so you mentioned pitch. For the audience that may not know what pitch is,
Yeah,
let's talk a little bit about the AI chips
yeah,
and how they're growing massively.
yeah,
And I think what's happening is as they get larger, the probe contact points grow,
yeah.
and you start running out of space.
Yes.
So you have to now shrink the distance between the pads. Can you talk about like where are we at in the industry with that, and how do we solve that problem?
Sure. Yeah. So it's also quite interesting and funny in a way that when I joined from ESML, you talk about nanometers and angstroms, and you come onto the back end test and measurement side, and you start talking about microns, right?
Mm-hmm.
So what is really happening is if you look at the overall semiconductor devices, right, and I'm not going to pick a particular one in terms of logic or memory, but in general, there's device scaling. So when you do device scaling, you're shrinking the device to have more transistors per chip, right? To have more memory per chip. So you look at historic, having a memory chiplet which would have, 64 gigabytes, and it'll be quite huge chiplet. Now, the same thing, you can get it in like, pretty small chiplet, the same size of memory. So overall device scaling is driving the density much more tighter. That poses a risk on the test and measurement side too.
Mm.
So as you shrink the devices to get more transistors, more juice out of the same chip, making things smaller, talking about the Moore's law and everything. So following that, the back-end test and measurement side, what was interesting is we had the leverage of having a particular pad size where you do the probe testing. And the pad sizes were, big enough, but now as you scale the devices small, it's not just the pitch that is scaling, it's also the pad sizes that are getting smaller.
I see.
So this is one of the requirements that the customers are pushing us, and this is also where FormFactor is focusing on, is to say, how are we going to scale? What is the minimum pitch that we can support in terms of probing? And not just the minimum pitch of these probes, but also you have to be exactly in the center of the pad to make sure that you have better contact resistance.
Yeah.
So both of these requirements are needed when you're talking about just the pitch scaling.
So let's put that into perspective, because I want to make sure the audience understands the enormity of the challenge, and that we're not talking about a few hundred pins here. We're talking about thousands and thousands of pins. I mean, how do you do that and have it planar?
Yeah.
And then how do you even Like what happens when something breaks and you need to repair it?
Yeah. Yeah, like I said, right? Like the industry is shifting more onto doing more and more tests now.
Right.
Right. The risk of not having known good dies is quite enormous. So, and not just it's known good dies, but it's also the test and measurement requirement is growing because now customers want to test different parameters. They want to test a lot more. So what is also happening is you need to have more pin counts. And that's number one. But the second thing is also as you start scaling and you start doing more parallelism,
Mm-hmm.
there are more pin counts that are required. And if
And
you
that's
look
to
at
drive the cost down because you can do more in parallel, basically. That's
absolutely,
one of the best ways to
absolutely,
drive and
absolutely,
scale down the cost.
yes. And this is where it's also interesting is you have different requirements for memory versus logic SoC applications and on the memory application side, the test requirements are different. So there you're talking about maybe you're still talking about wafer level, but you're talking about multiple dies together.
Mm-hmm.
So you're talking about 100,000 pins or more,
Oh, wow.
but you're doing multiple dies together. The test requirements are different. Customers push us into one touchdown solutions. And yes, it's no longer a few hundred pins. You're talking about 100,000 and more pins, right? On the logic SoC, it's also quite different now compared to memory. But there you have the test requirements are very different because you need different kind of parametric testing for the logic SoC devices. So you're still talking about one die, a singulated die, which will need few tens of thousands of pin. So in order to reduce cost, like you said, you have to do multi-sites. And when you start doing multi-sites, that is where you are talking about reducing cost by adding more sites to it. But the complexity in terms of this entire interface with the PCB and then the test programs that you have, you're talking about, by 4, by 10, by 16, depending upon the test complexity and how much parallelism can we do.
First of all, I still can't wrap my head around 100,000 pins somehow being coplanar.
Yeah.
But you obviously do that, so congratulations. I don't know how you do that, but that's amazing.
Yeah.
We were talking before the show about when I first started,
Yeah.
I was doing on-wafer probe testing
Yes.
using RF probes
Yeah.
from Cascade, which got acquired
Yeah.
by FormFactor, I believe, in 2016 or 2012, something like that. And those probes at that time, they were like angled and they would scrape to like bust the oxide and scrape onto the device.
Yeah.
But I'm assuming now, I mean, with 100,000 pins, you can't do that anymore. So how do you resolve that?
Yeah, so this is like I was talking about. FormFactor has a huge spectrum of applications,
Mm-hmm.
and if you look at the industry today, especially on the memory HBM applications, we have a product called Smart Matrix. So they are the 3D MEMS probes.
Mm-hmm.
And the requirements in terms of the bandwidth, the requirements in terms of the space you're talking about, it's very different. And the specification that you need for HBM applications, we have pioneered that. And that is very different than the logic SoC applications where you have vertical probes. And because on the SoC side, your current requirements are different compared to the force requirements and the bandwidth requirements. The materials are different. And we do have many of these different probe types that serve the segment market.
I see. Well, we do now have these vertical pins that, for, I guess, the easiest way to think about it, a bed of nails almost. It just comes straight down and makes contact. And you have thousands and thousands of those.
Smaller than a hair.
Yeah, smaller than a hair. That's amazing.
Yeah.
So do you do that also for stacked die so that's the pins are at different coplanar levels?
So for stacked die, again, we on the memory application side, you do wafer level tests, you do singulated die tests, you do stacked die tests.
Mm-hmm.
So there are many different applications. On the SoC side and the advanced packaging side, Yes, there are hybrid probing requirements that will need different kinds of probes on the same probe card. One thing I wanted to add is you asked about vertical and the 3D probes.
Yeah.
Customers ask, hey, can we use vertical probe for memory devices, or can you use vertical probes for RF devices, right?
Mhm.
So on RF, we call it P probes on flexible substrates. The requirements and the test measurements are very different.
Mm-hmm.
It's not that you cannot do it. Absolutely, you can use the same probe at many different places because at the end of the day, you need contact. But the test complexity is so different that you do need to optimize the tests, the materials, the spring type, we call 3D, 2D, flexible, for those applications. And that is where we have been spending a lot of time in, R&D to say, okay, what probe type is the best for customer applications?
I see. Yeah, that makes a lot of sense. Let's take a small tangent and
Hmm.
talk about FormFactor's history. Can you walk us through, I mean, what were the inflections or what was going on in the market
Yeah,
f- to have those acquisitions? I mean, was there
yeah,
some new technology that was
yeah.
required or what was happening in the market to make?
Yeah, so I'll try to do as much as I can. As you know, I've been with FormFactor now about a year and a half, right? But if you look at the history, right, it's not just a FormFactor history. If you look at the entire test and measurement industry, right, over the last 20, 30 years, there was a lot of consolidation, mergers and acquisitions over the years. And FormFactor has been there for a very long time. And some of these acquisitions, like the microprobe, they had a solution more onto the memory application versus FormFactor was pioneered in logic applications. So that is a good, collaboration where FormFactor acquired microprobe, and now Mike Slessor, our CEO, he came from microprobe actually. But all of this is, in parallel to what is needed in the semiconductor industry from back-end test and measurement side. You have to notice that similar kind of things also happen on the customer side. There's a lot of mergers, consolidation. It also happened in the front-end side.
Yeah,
You see that happening on the back-end side now.
yeah,
And over the years, Advantest did something similar, right?
yeah.
They've acquired so many companies in the past. As the requirements are getting more complex, there's more need for collaboration. There's more need for kind of mergers, acquisitions in a way you may call it, or partnership in the industry.
Yeah, I want to key off of your collaboration there. So one of the things we've heard in industry that's I think resonating with everyone is that the complexity of producing semiconductors is so great now
Yeah.
that there's no way to bring these products to market without very strong collaboration,
Mm-hmm.
even sometimes between competitors.
Yes.
We see that a lot. Obviously, we have some partnership
Yeah.
projects with FormFactor, especially with silicon photonics
Yeah.
and how the market is changing and
Yeah.
customers demand for us to do things and some of it
Yeah.
we can't do. And I'm sure customers demand you guys to do things and some of that you can't
Yeah.
do. So we're by necessity, we have to collaborate. So
Yeah.
let's talk a little bit about what sort of collaborations you see, not
Yeah.
just maybe with that
Yeah.
Advantest, but with you that you see with customers or with partners in general.
I'll take a step back. We talked about microprobe and form factor. Cascade is also interesting. So form factor, what we provide is we provide from lab to fab solution. Right?
Hmm.
So we do test systems, early R&D lab environment where we have test systems that measure from RF, DC applications. We have been in silicon photonics for quite some years now. And then connecting back to applications onto the HVM side where the probe cards are into more HVM environment. And we also have quantum cryogenic solutions where we look at cryogenic, it's also on the lab side today, but there are features and functionalities on the thermal side which are needed on the probe card side, for example. So this is where, even within form factor, we do have an ecosystem to go from lab to fab. Now, if you connect that with the outside world, we also look at collaboration areas on the vertical segment side. So FormFactor has always believed in open ecosystem, and similar to Advantest, actually, I appreciate and admire the fact that Advantest invested a part of it in FormFactor earlier this year. And similarly, you do it with other partners, because this is what the customers really require. They want an open ecosystem where we can give the best solutions to the customer, but it also fosters code development. It also fosters code development in a way that will kind of, expedite some of these roadmaps. Rather than doing it by yourself, you're collaborating and partnering and getting the solutions to the customers much faster. So FormFactor has also invested in FICT, which is more onto the substrate MLO side, to make sure that we similarly on how we work with Advantest, we work with the vertical suppliers too. So that is what is going on now. Switch gears to silicon photonics. This is one area where FormFactor has been in the market for a long time. We have shipped more than hundreds of systems of silicon photonics in the past. We have those application layers. And there's a need now. We are at this industry inflection point, right, where there's need for HVM solution. So this is where we partner with Advantest, because you are the pioneer and leader in ATE for HVM requirements.
So let's talk about that silicon photonics a little bit more. So first of all, just to sort of set this up, Jensen recently gave his keynote, and he showed the amount of copper in the backbone and how many miles of copper it is, or I don't know, it weighed 2,000 tons. And
the nuclear reactors needed.
Yeah, and the amount of energy that's required in the data centers that are being built, and the energy that's required to supply those data centers is largely because we're just moving data around. We're moving data from the CPU or GPU to memory and then back and forth. And so now there's this, as you alluded to, there's this emerging silicon photonics where we could move the data optically, which dramatically reduces the energy. Sounds great, but it introduces a whole new set of test challenges, because the interfacing and the form factor, pun intended, form factor is completely different.
Yes.
So talk to me a little bit about like what is actually changing, and what are the challenges associated with addressing silicon photonics and co-packaged optics?
Yeah, so if you take a step back, right, if you look at the data bandwidth requirement from test point of view, you cannot do it just by electric alone, right? You need optical and electrical I/O. And that is what Jensen was mentioning in the GTC, that if you look at industry, the optical I/O is needed for AI and hyperscalers. So the industry is already talking about, you hear about EPIC, you hear about CPO, co-packaged optics, and it's the silicon photonics is not new. It's been there in the industry for a long time. As a matter of fact, I was listening to one of the podcasts you had before with Dr. Wei. To me, it's been there. It's just like making sure that if you look at this inflection point in the industry, the need is today to say, how do we really leverage having both the electronics and optics together on the same chip, versus start testing it, because the need from the data centers, the need from the AI, everything is there. Now, it's easy said than done. The requirements are very different, right?
Yeah.
And now you're talking about measuring, optical chiplets and measuring electrical chiplets, and combine along with advanced packaging. So this is where the industry is headed. It's not if and how. It's not about are they going to do it or not. It's timing.
Yeah.
And the timing is now. So many of these customers are requesting at a much expedited level to say, when can you deliver silicon photonic solution for HVM today, right? And how fast can we do it? Now, what is happening is it's interesting. I hear this term called you're building a bridge while you're crossing it.
Yes.
Uh,
Building the plane while you're flying it.
that sounds scary.
Very dangerous.
But that is actually what is happening on silicon photonics side. As the industry is kind of streamlining and standardizing the test requirements,
Mhm.
but at the same time, the suppliers also have to provide solutions. And that is where more collaboration is needed. That is where more understanding about the entire ecosystem, the requirements, not just from the end customer, but even the foundry partners. So this is where FormFactor has been leading, working closely with Advantest and other suppliers and also the customers. What is happening is you mentioned about electronics and optics, and this is where we do hybrid testing. So we have, like I said, the silicon photonics solution where we measure optical signals, but along with the probe card in ATEs, we can also do electrical test. And this is where the co-package testing comes in.
And just to key in on one thing you said, silicon photonics isn't new. In fact, I was working on it back in 2007.
Yeah.
And we had working solutions. We even built modules to test optical parameters, but it never went to HVM.
Yeah.
So that's the difference where we are now, is now there's, because of AI, there's an HVM need for silicon photonics and co-packaged optics. It's not of, well, it's a nicety and let's still do research.
Yeah.
It's now, how do we integrate this in a cost-effective way into the entire solution, which then forces us to figure out how to test it.
Absolutely, absolutely. So it's no longer a transceivers, or it has to be integrated along with all these complex chiplets that we are talking about.
I'm just thinking about what Jensen talked about, but also we had AMD at our keynote, and they also showed how this is a necessity now. It's an absolute requirement. And the signal integrity, being able to bring optical signals in and out and have that get connected in some sort of economical HVM way, that is extremely challenging. And that was one of the biggest challenges we had back in 2007 is how do you get this fiber cable to line up and meet with some little interface on the chip? And of course you can do it, but it's very expensive.
Yes.
And the challenge is you need to do that in a less expensive, much less expensive way that can have a lifetime in production, not just in the lab.
Yes.
Because we were doing a lot of that in the lab. So I'm thinking that this is going to be one of the major, maybe I'm overspeaking here, but I think it might be one of the major growth areas for FormFactor, because it has to be done, or a lot of that has to be done on the probe card itself.
Yes. So you bring a good point, Keith. So if you look at the challenges that we have with silicon photonics today, right? I'm not going to name the customer, but you list the challenges. The challenges are, how can you correctly align the optical signals, the signal integrity, right? Or fidelity that you talk about on the optical side. The noise, actually, the vibration and the noise. The fourth thing that we talk about is basically the time to align, the time to measure, calibrate and measure. And interesting enough, the customer says HVM tools, how quickly can we ramp HVM tools? Because if you are in the lab environment, how many tools do you need versus the HVM requirements are very different. Today, we talk about test insertion 1, 2, like some customers say test insertion 2, 1. It's kind of muffled in a way. But those are the requirements from more silicon photonics today. Along with electrical testing, right? The next generation that you're talking about is to have everything on single probe card. That is something that, we continue to look into the roadmap to say, because today you're still talking about having silicon photonics application layer and a hybrid electric probe card, so you can test both of them. But now, can you combine it into a single probe card, for example?
Right.
So those are more hybrid solutions that we have to look into the future roadmap, collaborating with partners and suppliers.
Speaking of collaborating with partners and suppliers. I mean, this strikes me as it's pretty cutting edge technology.
Yeah.
So, but test, as you mentioned earlier, it's often, well, it still is, but it's very cost sensitive.
Mm-hmm.
So we tend to do cost in areas of the world
Yeah.
that are, let's say, somewhat geopolitically unstable. So how do you deal with, you're sending this
Yeah.
complex
Yeah.
piece of technology, you have to service and maintain it,
Yeah.
but it's in a different part of the world that's probably not so easy to
Yeah.
even, anyway, how do you do that?
So let me wrap up on the silicon photonics, and I'll talk about the cost. So when I was talking about, building the bridge while you're walking, that is true, because on silicon photonics, you're talking about different test insertions on how you're developing a solution, but it also depends on the end customer, the end design customers.
Mm.
Are they developing the chiplet into the same way? Are they going to have advanced package, which might be a different direction? So that might have requirements that change, and it becomes important for companies like FormFactor, for companies like Advantest, to quickly adapt to it and provide solution that is not easy and definitely not cost insensitive in a way, right? But the next question is that once you start supplying to these customers, and it's not just on the silicon photonics side, more onto the probe card applications too, what is happening is, yes, you're absolutely right. It has always been so much cost stringent. And I've worked with many customers and many buyers. And what happens is, when you're on the front end side, if you say, hey, I need, a few 100 million, it's easy to get it. But the same question you ask on the back end side, hey, can I get 10 million? And then you basically don't get the CapEx approved, right? So back end test and measurement has always been overlooked in the past. The complexity has been overlooked in the past, but things are changing now. So as the requirements increase, there's more cost pressure to the customers too. But it's also emphasis to say, how do they balance it? Now, that's on one side, but the second side is that pressure is still there. How do we manage and support it? So customers are kind of, migrating to lower cost region areas, or maybe they will have OSAT partners, which are in some region somewhere. And in probe card industry, you have to manage and service these cards similar to how the ATE service requirements work. So we have to manage that working closely with the customer, but at least understand customer roadmaps. This is also driven by geopolitical situations. Many governments are investing in semiconductor space right now. There are fabs, and there are OSAT, and there are test and measurement facilities popping up in many countries which did not have anything before. How do you create a service structure that's going to support these customers? So those are the kind of challenges on the service side, which does impact cost to the customer, but also cost to us. And at FormFactor, we look at this, and we work closely with the customers to really understand strategically how to have locations so that we can still have faster turnaround time. Because at the end of the day, that is money. If you have wafer sitting not getting tested, that is cost to the customer, and it's impact of money to the customer. So we have quite a bit of requirements to say service within 24 hours, 48 hours. And what we have done is we have strategically located these service centers across the world. As a matter of fact, we look at the volume, and we have just doubled our Taiwan service center capacity to support service and operations requirement in Taiwan, for example.
Not to get too far off in the weeds, but it's often overlooked how important just service and support part of that business is to our customers. I mean, the technology is great. Everyone wants to talk about technology. But HVM is all about uptime, reliability, and cost. And things break. Things need to be calibrated. And you need to do that in the most reliable, least costly way possible.
Absolutely.
That's a whole nother ecosystem. We'll probably do a podcast just on that. In terms of the maintenance, the cleaning, I would imagine that there's a good opportunity to use maybe some AI technology there to help decide when the cards need to be cleaned or refurbished or repaired. Do you have anything like that?
So it's an interesting thing. I get asked this question so many times, like how much AI are we really using on the server side, for example?
Mm-hmm.
Can we predict which pins are going to fail? It's very difficult. It's very difficult because when you manufacture probe cards, they're very much design specific, and each design will have different test requirements. However, over the years, there's a lot of knowledge and know-how on how you service these cards for longevity, right? So when we sell pro cards, we customers will expect, hey, how many touchdowns you're going to have. So we talk about the lifespan of pro card in terms of, okay, 1 million touchdown, 2 million touchdowns, and what does it take to have those 1 million or 2 million touchdowns? So regular servicing, making sure that if there are any damaged pins, then we have the capability to fix those things at the customer side. And it is complex. It is, sometimes we do this experiment actually. We ask customers to come to the service center and try to take a pin and then put it back in the guide plate, and it does take efforts, right? So when it is 1Z, 2Z pins, you can do it manually, but the moment you talk about multiple pins, then there are tools which can do it. So the overall turnaround time is still much faster.
I can imagine that. Again, that would be could be an entire ecosystem
Yeah.
unto itself. That actually brings me to a new part of the podcast I
Okay.
want to try out with you today.
Sure.
So I did an experiment with ChatGPT, the latest and greatest model, or one of the greatest, latest models, a 3.0 model. And I basically asked the question to speculate on what sort of innovations could happen with probe card technology over the next 5 years.
Hmm.
And it came up with some, I don't know, maybe plausible or science fiction ideas. And I thought I would throw these out at you and
Yeah.
just you could give some commentary on that's all science fiction, or maybe some of that's plausible. We can call this pin count prophecies.
Okay.
All right. So these are bold predictions by GP303. The idea was to get down to sub 15 micron verticals, but to do that, reduce the force by using electrostatic zero forcing. You'd have all these pins, they're pretty close. They create this electrostatic pull that you could get rid of or at least eliminate the force challenge that I'm sure is a considerable challenge when you're trying to connect 100,000 pins down onto a wafer. So what do you think about that? That would eliminate the scrub entirely.
Yeah.
And it would be perfect for bumpless backside power wafer testing.
Absolutely.
So is it science fiction or is that possible?
Wow. So I'm not a technology expert. I was thinking, should I wear my Meta glasses and ask Meta AI? But no, Keith, this is actually, it is not completely science fiction either, right? If you look at where the industry is headed, the pitch scaling, the pads scaling. So the sub, you talked about sub 15 microns. Maybe it's still further out in the roadmap, but yes, customers are driving the pitch down, the bump sizes are reducing, right? And the other thing that we did not touch base earlier is the G-force, right? So when we talk about touching, the probes touching the vapor, the materials are also getting sensitive to say, what kind of scrub mark do you want? At the end of the day, you want to make sure that you have good contact resistance. And how much force do you apply? How much overdrive do you do? So yeah, all of that is good, but the electrostatic zero G-force, I don't know about that, right? That's a far-fetched doubt.
Maybe 2035.
Yeah.
Okay, so the next one was the Matrix X contactor. So you mentioned something about matrix solutions that you have already, and I guess it took it to the extreme, saying, okay, what if you had 100,000 pins, full matrix contactor, where you had printed carbon fiber, and you combine that with MEMS micro actuators that could planarize all of the pins in real time?
I would say not maybe group of MEMS actuators, yes. And we do some level of, you can call it planarization. There's some proprietary thing which I can share, I cannot share, but I would say hundreds of thousands of pins with MEMS actuators, probably not, but to the level what is needed from different die requirements or even within the die. We already talk about hybrid probe today, right? So there are different requirements, which is reality, but individual actuators, that maybe not, right?
Yeah, I was thinking that I don't know if you would need that, and then if you did need it, it seems like it would drive up the cost
significantly, right? So
I mean, it would be cool technology, but
yeah.
Maybe you don't need that. They solve the planarity issues some other way.
Yeah. And like I said, right, every design you need a different card. Now, because the design requirements are different. Unless you have one constant design, which is standard, and you use actuators to justify the ROI, I don't see physical, practical implementation and whether customers would go for it or not.
Okay, so we'll give GPT a science fiction on that one.
Yeah.
Okay, the third one is on-card silicon photonics transceivers for co-packaged optics and HBM test. So this is essentially thinking about the probe card itself contains the optical transceivers, the gratings, filters, all of that, and is built in. Sounds like some of that you already do, but
yes, that is more close to something that that is needed on the roadmap, I would say. And there's a lot of attention and technology need from the industry too. I would say yes, that is more practical than science fiction.
Oh, I thought that one would be science fiction, but okay. That one.
Yeah, but like I said, implementation is always difficult. The need makes sense, right? So it's if you put it up in one card, that might be good.
If we can do it cost effectively.
Yes.
I mean, it's a long road to get there, I think, but yeah, it's an interesting idea. Okay, and then the last one was GPT took a term from your marketing, the contact intelligence, and came up with contact intelligence 2.0.
Okay.
Which was around self-healing, self-calibrating arrays, basically embedding AI firmware into the probe card that communicates when and what to do with regards to maintenance or serviceability, and maybe even regrowing. I think the term it used is relithiation, where say a pin got damaged or broken, and it would regrow that pins and I guess in some service.
That sounds very futuristic AI thing, but I think it is more.
Had this next year.
I don't think regrowing a pin. No. It's a great wish list actually.
Yeah.
If you think about it, yeah.
Like lizard regrows its tail, so you can regrow the pins instead of pulling one out and putting another one in.
I wish probe card was so easy. But some of these AI applications are needed from regrowing a pin. We just talked about the complexity of each of these probes that we are talking about. Every technology string, the probes are getting more and more complex. Right. We have factories and we work on those long. Just the processing of these probes also takes weeks. Right. Regrowing something at a service center from a wafer somewhere, that's a far-fetched doubt. It would be much more easier to have somebody go and replace it.
Much cheaper, much faster.
Much cheaper, much faster.
Okay, science fiction on that, GPT. I'm just curious, for these some of the most advanced probe cards, how long does it take to get from the design of a probe card to actually having a probe card where you can use it?
Oh, wow. You're going to put me on spot for that. I think it varies quite a lot. right? Sometimes when you're talking about the new design, and it depends whether the customers are going to do the design, whether we have to do the PCB MLO design versus the actual card design, right? So time varies on that, but it can range anywhere from 8 weeks to 12 weeks.
Okay.
Some complex design could even take longer. So we talked about high
I thought you were going to
parallelism.
say much longer because it's so complicated.
Yes.
Go ahead.
No, but high parallelism and everything also takes much longer. Now, what is happening is all the customers, they always ask to squeeze everything in as fast as we can. And this is where you can use some of these AI applications to help you speed up on.
Exactly what I was going to ask.
Yeah. So there are opportunities where you can speed up more onto the design side. And on the factory and operations, we continue to look at that. We continue to look at ways to automate it and speed up the process, similar to how the foundry partners are doing. They speed up their process. We do the same thing on our probes fabrication process point of view. As a matter of fact, I was going to segue into the capacity needs, right? So we just acquired a factory in Farmers Branch. We're going to double down. We have about 50,000 square foot of clean room space. There's significant need in terms of the overall capacity requirement from the customers. So that's one of the reasons we got this factory, and more capacity is needed.
Yeah.
And that will also help in terms of the overall cycle time, lead time that you're talking about.
Yeah, we see that too. We had a little bump in the road earlier this year, but things are looking pretty good.
Yeah.
At least everything that we're seeing with customers and what's going on in the industry. I think it's an interesting market to be in right now. Okay, so that does it for pin count prophecies. Thank you for painfully going through that with me.
No, it was a joy and a pleasure, Keith.
Yeah, I think that was fun. Okay, so what I want to do next, we have the lightning round.
Okay.
I came up with a few questions just to throw at you real quick, and then you can, whatever comes off the top or comes to the top of your mind, you can talk about that. The first one is the biggest myth about probe cards or the biggest misconception. Go. What's the biggest myth or misconception about?
I'll tell you, it's also something that I had that before. I'm like, yeah, probe card. You talk about micrometers. It should be simple. It's a commodity.
Voltage and current.
It's just like pins that touch. But the more you get to know, the more complex it is. So it's not as simple commodity as many people misinterpret that. And it's a myth that, oh yeah, it's a probe card. Back end test, it should be simple, but it's way complex than when people take it. So a lot more thing into, cost, commodity. That's what people think about, but it is not. It is way more complex technology than it appears from outside world.
Yeah, it definitely sounds like it's an enabling technology. You can't get the products to market without it, so you're a critical path, I would say. But you're juxtaposed against it's a consumable.
Yes.
Right? So it's consumable, so they don't want to pay much for something they're going to end up throwing away, but you absolutely have to have it.
Yeah.
Interesting dichotomy that you have there. Okay, what the most underrated metric everyone should track but rarely does? So we talked about like lifetime or cost. And what do you feel is the most important metric that people don't look at or that they should look at?
I think we talk a lot about technology roadmap and all of that, right? I'm not going to speak about that. That we collaborate, partner with the customers. I think you're right in terms of quality, lifetime repeatability, and consistency is what is also needed on the probe card. Because at the end of the day, the better quality you have, to me, this is where we can help the customers in terms of MTBF, MTBI, and the cost, right? And getting reliable, consistent results with a probe card, I would say that's like most underrated today. Okay. Technology requirements, we can get it covered early enough, but people do tend to underrate quality on this aspect.
And could you describe for the audience MTBF and MTBI? What does that mean?
So mean time between failure, mean time between interrupt. What happens is when you're testing the wafer and the devices, and your card is there, if you talked about a pin failure, for example, if a pin fails, then you cannot test a wafer.
Mm-hmm.
So that means you have wafers sitting on the floor without getting tested. To me, that is the time, and the time costs customers money because you cannot get those dies out and you cannot sell those dies to the end consumers. So that's why, what we talk about, I give reference of front-end process. When a tool is down, you cannot process the wafer. Same thing happens on the back-end side. If you cannot test the wafer is just sitting there. That's, to me, that's quite cost impact to the customer.
Mm-hmm.
So having better quality, longevity, and a support model that we were talking about, that you can respond to the customers faster, or have solutions that the wafers are not going to be sitting there. That's something that we put focus on, we put emphasis on, and we ensure that we have a policy called first time right, actually. We don't talk about dead on arrival, we talk about first time right, and we put a lot of emphasis on that. And it is becoming more key. Otherwise, what happens is if you don't have good quality products and you have to throw people to fix issues in the field. So it's better to focus on it up front, make sure that you have good quality products with better mean time between interrupt or failures. That saves people money.
I'm sure your customers have heard about it.
Yeah.
But that makes a lot of sense.
Yeah.
Not dead on arrival, but let's make sure everything's first time right.
Yes.
Okay. Then the last one, I mean, both of us have been in semiconductor industry for the better part of 3 decades. What career advice would you give your younger self after traversed not only now the colorful front end, and now you're on the more dramatic back end? What sort of advice would you give your younger self?
I would say I would split it up into 2 parts, right? One is getting the breadth of the technology. What happens is when you're young, you're so focused on proving not just to your management but also to yourself you can grow. And you have the blinders on, or blinders on, and you're just focused on it. I think getting the breadth of technology, and you always hear this term, be curious, right? Be hungry, be foolish, in terms of understanding I would have loved if I had that level of understanding of the entire semiconductor ecosystem back then. So getting more onto the breadth of it would be one area. The second thing is, I'll tell you personally, I've gone from very hardcore R&D, where I know what I have to do, sitting in the cube, to sales side, where I talk to a lot of people. I think more onto team collaboration, speaking to people in the industry. That would be the other area that I would advise myself if I was back in 25, but also to the young college kids who are there today, right?
Yeah, you actually triggered another thing. The complexity of the semiconductor industry is enormous. I think everyone would benefit if they had a much broader understanding.
Yeah.
Like I have bits and pieces of the front end, but not a really deep understanding of it at all. But now with AI, you have experts in every topic, every domain. So I'm a bit envious of the new graduates coming out of college, because they can actually achieve that because they have these experts.
So much of knowledge
sitting right there that know the last 50, 60 years that we would never, even if we would have tried to do this, we would never been able to achieve it, because how would you acquire that knowledge?
Actually, that is true. If we had AI, I didn't think about it. If we had AI back when we were 25, I don't know what advice I would have given to myself. But yes, the knowledge is there.
Yeah.
Right. It's where you spend your time, and which are the directions that you want to grasp. The pool of resources that are out there today, just enormous.
Is there anything else that you want to cover?
No, I think we're good.
All right, so that wraps up another episode of Advantest Talk Semi. A huge thank you to Ashutosh Devitt for taking us from the early microspring days through HBM, AI accelerators, and even cryoprobe test. So your inside look at how FormFactor engineers' first contact for tomorrow's chips was equal parts masterclass and inspiration. So listeners, if you'd like to dive deeper, replay Ashutosh team's technical session from Southwest Test 2025. You can catch both FormFactor and Advantest at SemiCon West 2025 in Phoenix, October 7th through the 9th. You can, of course, see the links to the podcast and the websites and below in the channel. And if today's conversation sparked an idea, share it. You want to comment? Do so on the Advantest Talk Semi episode with a colleague. Leave us a rating, and of course, be sure to subscribe and never miss a bite of semiconductor insight. So I'm Keith Schaub signing out. Thanks for joining us on Advantest Talk Semi. Until next time, keep pushing the limits of test. Thank you, Ashutosh.
Thank you, Keith.